Hello, greetings of the day. Now here we are presenting my next video, that is a task control block. In the previous some videos, we have started the kernel structure part 1, part 2. In that we have covered the task create function and the definition of the task, that is a task is an infinite loop. Then in the next part of the videos, we have seen the task states. Now we are very much clear idea about the some listings, important listings on and the task states of the kernel. Now here we are in the position to understand the task control block. So I have created the two parts of this task control block, that is a task control block part 1 and the task control block part 2. Now here we have to start the task control block part 1. Now, the task control block is the structure. The structure task control block, which is denoted as OS underscore TCB in the kernel. Now, why it is called as a structure? Whenever the name structure is there, then we have to keep in mind we need not to forget or we do not to forget our C language, the concepts of the C language. Already I told that our kernel is written in a C. So all the concepts of the C functions, C structures, C linked list, every concept is utilized to write the kernel. So here just we have to remind that the task control block is the structure, and whenever the name structure is there, the task control block we can define the task control block is a data structure. Task control block is the data structure that is used by MuCOS2 to maintain the state of the task when it is preempted. We have seen that the MuCOS2 is a preemptive kernel. Hence, whenever the high priority task is asking for the request, the MuCOS2 has to give the CPU control to the next high priority task. That time, at the time of preemption, the MuCOS2 is following the context switching concept, where while switching the context, the CPU has to save, or the scheduler has to save, or the kernel has to save all the states of the previous running task into the task control block. And that's why the task control block is a very useful data structure. Task control block is very useful data structure used by the MuCOS2 to save the state of the task when it is preempted. Now, when the task regains the control of the CPU, that time it allows the task to resume the execution of the exactly where it is left off. So keep the track of the task where it is left off, and again we have to resume the task from that state. The task control block plays very important role. Here, here we can take an example of the book reading. Whenever we are reading the book, and in between we have to do the another task, and we had read the book up to the page number 20. Then when we will come back, we will start from the page number 21. We are not starting to not starting reading from the page 1. Means we have to keep the state in a mind that I have to start from the page number 21. Similarly here, task control block keeps the track where the task is left off and where the task has to regains the control of the CPU. Okay, hence the structure is very much essential to keep that track. Now, this diagram says that this is a memory block. Whenever the structure word is there, this is the memory block. And such a memory block where all the member variables are saved sequentially. And to happen this, the programmer has to write the structure in a C language. So here, this diagram says that OS underscore TCB is the memory block or the data structure which are having the different number of members or the data variables which are essential to save the status of the task. So this is the definition of the task control block, and these are just a variable or the memory block shown in the figure. Now here we will take again the clear scenario that what is the context switching. In the context switching, that we have to keep in mind that there is only one CPU is there and the CPU register set is only one. But we are saying that the mucos 2 or the only real-time application having the multiple tasks has to perform. Hence, assume that there are the task 1, task 2 or up to the end task are there. Then how the CPU will keep the track or keep the track of the multitasking operation of all these tasks, so that there are the two important structures are there, stack and the task control block. These two structures plays very important role in the context switching, and those are present in the memory. Those structures are present in the memory, and the CPU is present in the at the hardware level. So the every task has to switch from one task to the another task according to the given or the assigned priority. So the task control block here, this diagram clears that every task is having its own task control block and its own stack. Every task is having. There is a no one combined or the common stack or the common TCB. Every task is having its own TCB and its own stack, and this plays very important role in the context switching. Hence, now we can realize that the task control block, which is the data structure, plays the very important role. Now here we will see how the task is written or how the structure is written in a kernel, so that we will get the clear idea about why it is essential or how it is saving the data into the particular variables. So for this, I have given here example of the structure. In the C language, we can relate this normal C structure with this OSTCB structure, so that you will get the clear idea about the structure. So, my dear friends, you know that whenever we have to write the structure, why we are write the keyword struct to say the compiler that here all the variables we have created in the structural manner. Then struct is a keyword. Here student. Okay, whenever we have to create the structure or to save the database of the students, we are giving the appropriate name to the structure, that is a student or the stud. So here I have given the name as a stud. Then inside the curly bracket, we have to define the members of the structure. So whenever we are writing the list of variables in this under the structure, the compiler provides us the sequential memory allocation for all the data or all the data members written in the structure. So here we can say we have asked for the two memory locations, roll number and the name. So we have created the structure for the roll number and name. Okay. So these are the data members, or we can say structure members. The structure members are saved in a or saved in a sequential manner in the memory block. Now, what is this S1 and the S2? S1, S2 are the variables of the structure. So I can say that when I am writing here S1 and the S2, I have the compiler will provide me the two different structures for student S1 and again the one more structure for the student S2, where student S2, where again we can save the roll number and the name of the second student. Roll number and the name of the second student. So in this way, the structure helps us to keep the database in the form of the memory block, and number of such a variables we can create with the same structure. So this is the just review or the this is just the review or recalling of the structure how it is written in a C. Now we will compare this our OSTCB structure here with the normal structure. See here the struct keyword is written over here. Struct is the keyword, and OS underscore TCB, which is in the small caps, small letters, OS underscore TCB is the name of the structure. Then here the structure curly brackets starts. Then their different variables are defined in the structure and having the different data types. So here, whenever we have to write the member into the structure, we have to write the data type of the particular variable and name of the variable, where we have to save the appropriate information. Variable name itself gives the idea about what is the purpose of that variable. So here also we can see there are the different variables are written into the structure. Here it is the end of the structure. Here it is the end of the structure. And here OS underscore TCB, which is written into the capital letters. OS underscore TCB here is in the small letters, indicates the name of the structure, and OS underscore TCB, which is written into the uppercase letter, this indicates the variable of the structure. So you can realize that we can create the number of memory blocks. Suppose this is a one memory block for the OS underscore TCB. For this OS underscore TCB. OS underscore TCB. We can give the name of the variable like this, OS underscore TCB 0. So we will get the one memory block for task as a task control block 0. Similarly, we can create the number of variables by writing as a OS TCB1. We can create the another structure as a OS TCB1, which will again having the same variables. What variables? Whatever we are written inside the structure, but the name of the block is the OSTCB1. Means this structure having the OSTCB as a name of the structure and OS underscore TCB in the uppercase letter as a variable of the structure. And if you can realize, we can create the number of variables of the same structure. Means we can create the number of memory blocks with the same structure. Okay? So this is all about the structure name and the structure variable. Now we have to look on the structure members. So all these are the structure members. See, this is a kernel. Lot of data types and lot many members are there because this is a kernel. This is not a normal simple user defined program. This is a kernel should have to keep the track of many variables. So here just look out that in the next video we will see all the details about all the members of this structure. Here just we will concentrate on the data types and the name of the structure variable. So here we can say the OS underscore STK is the data type of this particular variable, and this is a pointer variable OS TCB STK PTR. This says that the OS task control block stack pointer. This is the member of the structure. Then another member of the structure is the having the data type void, and the name of the member is a OS TCB extension pointer. Then again the next data type is a OS underscore STK, which is again holding the pointer variable, that is OS TCB STK bottom. The star indicates the pointer variable. Means here we are making the list of the different members of the structure which are located in the all these sequential memory locations of the OS underscore TCB variable. Then the another is the IN32U is the another data type. See, these are not a normal data types. Normally we are aware with the INT, string, character, such a data types. But these are the data types specially written or the macros are created for these data types. All these OS STK, OS underscore STK, INT32U, all these are the hash defined macros written into the kernel so that we can use that as a temporary data types for the to write the kernel. Then INT32U is the data type and OSTCB STK size is the member of the structure. Then INT16U OSTCB OPT is the another member of the structure. INT16U OSTCB ID is the another member of the structure. Here just we are reading the name of the structure. In the next video we will see all the details of this. Then this is the structure OS underscore TCB. Now here we have to concentrate what is the data type. Structure is itself a data type which creates the another structure named as a OS TCB next. Then we have to see the details of this also in next video. Structure OS underscore TCB is the data type. Star OS TCB previous is the another variable or the member which is having the type as a structure again. Then OS underscore event is the data type again, and OS TCB event pointer is the structure variable. Similarly, here we can see int 16u, int 8u, int 8u, and the TCB DLY, TCB static, TCB priority, TCBX. All these are the variables or the members of the structure. So we can say that what we have seen in the previous diagram, here, like this structure, whenever the compiler will execute this structure, it will allow us the such type of memory block where all the members are holding their position in the structure. Okay, so this is all about the how to write the OSTCB structure. What are the structure name is there? What is the structure variable? And what are the different members of the structure? So in the next video, we will concentrate on more details about this structure members.